Hello everyone, my name is Neha Agrawal and my topic is concurrency and problems. So before understanding about concurrency, let's have a brief introduction about what is transactions. So transactions are the set of operations that are considered as a unit of work. Let's look at the definition. Sequence of operations that form a single step transforming the server data from one consistent state to another. One more point to keep in mind is that transactions are indivisible. They are atomic. Now let's understand it more deeply with the help of a real life example. A banking transaction for a customer at ATM. The transfer of 100 rupees from saving account to checking account, transfer of 200 rupees, withdrawal of the 400 rupees. So all these are like transactions in the real life. Now let's look at a bank server where will have a look at account and branch interfaces. So the operations that we perform at account interface is depositing of the amount in the account, withdrawal of the amount, returning the balance, setting the balance of the account to the particular amount. Operations of the branch interface are creating a new account with a given name, returning a reference to the account, return the total of all the balances of a branch. So now the transaction failure modes are there are several transaction failure modes that are displayed here in which 1, 3 and 5 depicts a failure where the customer loses the money. The point second and fourth represents the failure where the customer will not lose the money, but the old steps cannot be repeated. The point seven depicts that this is the point of no return, a failure after the commit point. ATM crashes. So it needs corrective action. Now the transactions in traditional databases has the famous ACID properties, where A stands for atomicity, means either all the operations would get executed or nothing would get executed. If, for example, two operations got executed and the system failed, so in that case, everything would be rolled back to starting and everything would be start from the beginning. C stands for consistency. Means if the server starts in a consistent state, the transaction ends the server in a consistent state. Isolation means when multiple transactions occur at the same time, all the transactions would remain isolated from each other. They would not interrupt with each other. D stands for durability. Means after a transaction has completed and all the changes had been made to the database, it will remain permanent after it got committed. After it commits, it will not get changed. So this is durability. Now let's understand concurrency, which is our major topic. In multi-user environments, multiple transactions occur at the same time. This is concurrency. And if it is not managed properly, there are many issues that could arise. For example, lost updates, dirty read, or inconsistent data. We will discuss all of them in detail further. Concurrency control ensures that all the transactions would execute it properly when they are running simultaneously. Now, there are four major problems that are caused by concurrency. These are lost update, dirty read, inconsistent retrieval problem, and phantom read problem. So we'll discuss them one by one. First is a lost update problem. Here, when multiple transactions, here we will take example of two transactions. So they are trying to make changes in one value, same value. So the updation that is made by one transaction would get overwritten by the updation of the other transaction. Here we'll take example where we have three variables A, B and C. Value of A is 100, B is 200 and C is 300. Like for example, A is having money of 100 rupees, B is having 200 rupees and C is having 300 rupees. Now transaction T1 occurred first. So we'll get the balance of B that is 200. Then transaction T2 occurred, where we'll again get the value of B as 200. And we will set the balance by multiplying the value of B with 1.1. So B's value will become 220. Now, after T2's two operations, T1's operation got executed. So now its balance, B's balance will be multiplied by 1.1. But here the B's value that is set by T2 will not be taken. Here, the B's original value of T1, that was 200, would be taken, and its value would be set to multiplied with 1.1. So, balance would be set to 220. And so, the B's value, the updation made by T2, got overwritten. Now, the B's value would become 220. Now we will withdraw the value of A. We will withdraw the value from A. So it will be 100 minus 20, that is 80. And after this operation of T1 that got executed, operation of T2 will get executed. And we will withdraw the amount from C, that is 300 minus 20, that is 280. So here T2's update got lost. Now, this happens when two transactions read the same data and update it, but one's update gets overwritten by the other. So here is another example where there are two users that are updating the stock of a product. Transaction A reads the stock as 50 and make it as 45. At the same time, transaction B also read it as 50 and make it as 40. Since both updated the original value at the same time, once update gets lost and the final stock would become 40, ignoring A's update. So this is our lost update problem. Now let's move to another problem, that is inconsistent retrieval problem. Here, the partial or incomplete results of one transactions are retrieved by another transaction. So here also A is having 100 rupees, B is having 200 rupees, and C is having 300 rupees. And here two transactions are occurring in such a way that T1's partial result is used by T2, giving the wrong result for T2. For example, let's take another example. A bank app is calculating balance of a customer's two account. Customer is having two accounts in a particular bank and the bank is calculating the balance. While it is reading, another transaction transfers money between the two. So there is a transfer of money between those two accounts in a bank. The, what would be the result? The total balance looks wrong or inconsistent, even though the real money has not changed. So this is our inconsistent retrieval problem. Now let's come back to third problem, that is phantom read problem. This occurs when a transaction reads a set of rows matching a condition, but another transaction adds or deletes rows during the transaction, and the re-execution of the query gives a different set of rows. So let's understand everything with the help of example. There is a transaction A which will run a query where it will select all the quantity that is great, all the data where the quantity is greater than 100. So it would get all the data where the quantity was greater than 100. Now at the same time, transaction B inserted a new order where the quantity is 150. So if A runs the same query again, it's a new phantom row appears. So it's not that the data changed. It's that entire new row appeared unexpectedly. So this is phantom read problem. Now the most famous problem, that is dirty read problem. This occurs when one transaction reads the data written by another transaction that has not been committed yet. Like suppose A and B, there are two transactions. A has made some changes in a transaction A has made some changes in a particular value, but it still didn't commit it. Now transaction B had accessed that particular value that was updated by transaction A. Now after some time, the transaction A got failed, but the transaction B had read the value that was updated by A. So in this case, transaction B has carried the value that was wrong. Let's take another example. Transaction A updated a bank balance from 1000 rupees to 500, but has not committed. Transaction B reads this new balance and continues processing. If A rolls back, now B has made decisions based on that data technically never existed. That's a dirty read using unconfirmed dirty data. So there is an unconfirmed data that would be processed by transaction B. This can lead to serious inconsistencies. Now there are several concurrency control techniques. To manage concurrency, there are several techniques that had been developed. First is log-based protocols. So here we use logs, where data is logged to avoid conflicts. Timestamp ordering means it gives each transaction a unique timestamp, that in this timestamp, in a particular timestamp only, that particular transaction would get executed. Optimistic concurrency control, which checks for the conflicts only at the commit time, assuming they are rare. Now, there are various concurrency control techniques, which includes serial equivalence. An interleaving of the operation of two or more transactions is said to be serially equivalent if the combined effect is the same as if these transactions has been performed sequentially in some order. So this is serial equivalence